A sloth, a donkey, and a curious human. Send a prompt and see what they're doing. One hits record with a question on his mind. Two brothers pick it up, see what they find. Corn takes his time, Herman's got the facts. Back and forth, they never hold back. My weird prompts, come on in, that's where we begin. My weird prompts, glad you're here.
This episode was generated using artificial intelligence. Please verify facts.
You know, Corn, this whole show runs on GPU compute, and we wouldn't be here without Modal.
Seriously. And that's what powers all our text-to-speech. Everything you're hearing right now.
They're an AI infrastructure platform. Developers use them to run GPU workloads in the cloud with zero infrastructure headaches.
If you're building anything with AI, check them out. Modal.com. Imagine you are sitting at your desk, and 3 different AI agents are all logged into your main repository at the exact same time. One is deep in a massive refactor of your authentication logic. The second is halfway through implementing a new dashboard feature that, of course, relies on those very same auth hooks. And the third is a hyperactive bug fixer that just noticed a typo in a shared utility file and decided to, helpfully, rename a bunch of exported functions. This isn't a hypothetical nightmare anymore. It is the daily reality for teams pushing the limits of agentic workflows. Today's prompt from Daniel is about the coordination chaos of multi-agent code generation in shared repositories. We are looking at how to prevent the absolute regression hell that happens when you have parallel agents working in the same codebase without any real coordination primitives.
It is the too many cooks in the kitchen problem, but the cooks are running at 10,000 words per minute, and they do not have eyes on what the person at the next station is doing. By the way, today's episode is powered by Google Gemini 3 Flash. I am Herman Poppleberry, and I have been obsessed with this specific bottleneck because, frankly, our current tools are not built for it. We have spent decades perfecting Git and CI pipelines for humans who communicate in Slack and stand-ups. Agents do not do stand-ups, they just execute.
And that is the rub, right? We have tools like Claude Code, which is now apparently handling 4% of all GitHub commits as of March 2026. That is a staggering amount of automated churn. When you have one instance of Claude Code or a single Devon task running, it is manageable. You are the supervisor. But the moment an engineering lead says, all right, let's spin up 5 agents to knock out these 10 Jira tickets in parallel, the traditional guardrails just melt.
They really do. The core issue, as Daniel pointed out, is that while we have sub-agents for delegating small subtasks within a single thread, we completely lack the primitives for managing discrete, parallel projects across a single repository. If Agent A and Agent B both pull from the main branch at 10 in the morning, and Agent A finishes a massive architectural shift at 10:05, Agent B is still working on a ghost version of the code. When Agent B tries to push, you don't just get a merge conflict, you get a logical lobotomy of your codebase.
I love that term, logical lobotomy, because it is not always a merge conflict that stops the build, is it? Sometimes the merge is clean, according to Git's line-based logic, but the actual execution logic is now completely bifurcated. So, Herman, why does this happen? I mean, we have had concurrent versions of software for 30 years. Why can't agents just use branches like the rest of us?
Because agents operate on local snapshots and, crucially, they lack intent awareness of their peers. When a human works on a branch, they usually have a mental map. I am touching the API layer, so I should probably check if Sarah is doing the same. Agents don't check. They are stateless between hits or confined to their specific task context. If you give 5 agents 5 different branches, you end up with PR noise that no human can possibly review. Imagine coming into work and seeing 40 open pull requests from Agent 7 and Agent 12, all of them touching overlapping files. Who is going to audit that?
Certainly not me. I'm a sloth. I barely want to audit my own breakfast choices. But seriously, the volume is the enemy here. If the solution to agentic chaos is just have a human review it, then we have just moved the bottleneck from writing code to reading code, which is actually more exhausting.
Well, not exactly in the forbidden sense, but you hit the nail on the head. The bottleneck shifts. If you use a branch per agent model and those agents are fast, you're essentially DDoSing your own senior engineers with code reviews. And if you don't review them, then you're just praying that your test suite catches every single side effect of 5 simultaneous architectural changes. Spoiler alert, it won't.
So we are talking about a need for transactional semantics for agent actions, like a database, right? If I am updating a row, you can't update it until I am done. But applying that to a repository of 10,000 files seems, complicated.
It is incredibly messy. Most agents today use naive merge strategies. They use a read, modify, write cycle that is totally decoupled from the other agents. We need something more like semantic locking. Imagine if an agent could broadcast to a coordinator, I am currently refactoring the user service.typescript file with the intent of changing the interface of the login function. A coordinator could then tell another agent, hey, wait a second, you're trying to add a feature to the dashboard that calls that exact function. You need to pause or subscribe to the first agent's changes.
That sounds like a supervisor agent or an orchestration layer. I know Microsoft released Magentic 1 back in January, which tries to do some of this task decomposition with a shared context. How does that hold up in a real-world repo?
Magentic 1 is a great step because it introduces a lead orchestrator that manages a registry of what everyone is doing. But even then, it is often confined to a single session. The real chaos Daniel is talking about is when you have multiple independent sessions or different teams all pointing their agentic tools at the same repo. It's the crosstalk that kills you. I was reading a case study recently about a team using Claude Code in their CI. Agent A was tasked with updating an old library version. Agent B was adding a new feature. Agent A finished, merged, and the library update changed the signature of a common helper. Agent B's tests passed on its local branch, but when it merged, the entire production build went dark because the intent of the helper had changed in a way that the line-based merge didn't flag as a conflict.
That is the nightmare. It's the silent regression. It's not a syntax error, it's a behavioral drift. So, if Git isn't enough, what are the emerging frameworks that actually stand a chance? I've heard people mention LangGraph for state machines, but that feels more like it's for building the agent, not managing the repo.
LangGraph is useful for defining the flow of a single agentic system, but for repo-level coordination, we're seeing more specialized approaches. Have you looked into how Devon handles this? They use a virtual file system with change batching. Instead of just writing to a file, the agent's actions are recorded as a series of proposed transformations in a sandbox. These transformations can then be replayed against the latest main branch to see if they still make sense. It's almost like a Git rebase on steroids, performed by a model that understands the code.
Okay, but replaying transformations still feels like it happens after the work is done. It's still reactive. Is there any way to be proactive? Like, can we give agents territories?
That is actually a strategy some developers are using right now. One developer, Ricky Smith, wrote about using Git work trees to manage this. Instead of one giant messy directory, he creates a single directory structure where each agent gets its own work tree. These work trees are all synced to the same branch name, but they provide a separate physical workspace. It prevents the agents from stepping on each other's toes in the local environment, but you still have the sync problem at the end.
I like the idea of work trees. It's like giving each cook their own prep station, but eventually they'll have to put their ingredients into the same pot. If the pot is the main branch, the conflict just moves to the final 5 minutes of the task.
Right, and that is why some people on the vibe coding forums are suggesting the complete opposite. Don't parallelize at all. Or if you do, use the two-agent strategy. One agent writes, one agent reviews. They act as a pair programming unit. This doesn't help with speed, but it drastically reduces the regression hell, because you have a second brain whose entire job is to say, wait, if you change that line, you're going to break the API contract we established 3 minutes ago.
That feels very safe and very slow. If I have 10 agents, and I'm using them as 5 pairs, I'm only getting 5 threads of work done, and I'm still worried about those 5 threads colliding. It feels like we are missing a traffic controller for code.
We are. We need a repository coordination layer. Think of it as a specialized piece of middleware that sits between your agents and your Git provider. This layer would maintain an AST and abstract syntax tree of the entire codebase in real time. When agent A says, I want to modify function X, the coordination layer locks function X and all its direct dependencies. If agent B tries to touch those same nodes in the AST, the layer rejects the request and says, resource busy, agent A is refactoring this.
Now that is interesting. AST-based locking instead of file-based locking, because two agents could technically work on the same file if they are touching completely different functions that don't share state, right?
Precisely. Well, I shouldn't say that word, but you are correct. If I am editing the header component and you are editing the footer component in the same layout.jsx file, there is no logical reason we can't both work simultaneously. Line-based Git might struggle if we both add imports at the top, but an AST-based coordinator would look at that and say, these are two independent leaf nodes. Proceed.
This makes me think of the vector databases as a file topic we've seen popping up. If the agent has a high-fidelity real-time map of the repo, not just a stale index, it can be polite. It can check the map to see who else is in the building.
Because, but this requires the agents to be spatial. Currently, agents are very linear. They think, I have a task, I will read the file, I will write the file. They don't have a persistent peripheral vision of what is happening in the rest of the building, as you put it.
So, let's talk about the architectural drift. This is the second-order effect you mentioned in the plan. Even if we solve the merge conflicts, what happens when Agent A decides the project should use functional programming patterns, and Agent B, working on a different module, decides object-oriented is the way to go? They both finish their tasks perfectly. The code merges cleanly. And now your codebase is a schizophrenic mess of two different design philosophies.
This is where it gets really scary for engineering managers. Humans have a vibe or a style guide that they mostly follow because they talk to each other. Agents will follow the style guide you give them in the prompt, but prompts are never perfect. If Agent A's prompt is slightly more verbose and Agent B's is minimalist, the codebase starts to drift. Within a month of high-velocity agentic work, your repository could become an unmaintainable patchwork of conflicting patterns.
It's like a city built without a zoning board. You have a skyscraper next to a farmhouse. It functions, but man, it's ugly and hard to provide utilities to.
And that is why the supervisor agent isn't just a luxury, it's going to be a requirement. We need a staff engineer agent that doesn't actually write code. Its only job is to sit at the top of the hierarchy, look at the proposed changes from all the junior agents, and say, no, Agent B, we are not using classes here. Rewrite this as a functional component to match what Agent A just did in the core library.
I can already hear the developers groaning at the thought of an AI staff engineer rejecting their AI junior engineer's code. But it makes sense. You need a single point of truth for architectural intent.
You really do. Another practical strategy I've seen, and this is something people can implement today, is intent-based commit messages. Instead of agents just saying fixed bug, we require them to output a JSON schema of their intent. I modified these files, I changed these exported types, and I expect these side effects. Then your CI pipeline can run a conflict checker that compares the intent schemas of all pending PRs. If two PRs claim to modify the same intent area, the CI flags it for a human before the code is even reviewed.
That seems like a solid low-tech way to start. But what about the context window problem? If you have 5 agents working, and they all need to be aware of each other, doesn't that mean their context windows are going to be stuffed with what everyone else is doing, instead of how to solve the task?
That is the big trade-off. Do you spend your tokens on work or on coordination? If you have a 100,000 token window and 80,000 tokens are just, here is the status of the other 4 agents, you're not going to be very effective at the actual coding. This is why I think the coordination layer has to be external to the LLM. It should be a specialized tool, like a custom Git extension or a server, that the LLM queries only when it needs to.
Like a checkout system for code. Hey, I'm about to touch the auth module. Is it clear? No, Agent C has a lock on it for another 3 minutes. Okay, I'll go work on the CSS instead.
And that brings us to the transactional idea. Imagine if agentic frameworks like LangGraph or AutoGen had a built-in distributed lock manager. Before an agent can call the Write to 2 Files tool, it must successfully acquire a lock from the manager. If the lock is held, the agent is forced into a wait state or told to find a different subtask.
That sounds like it would actually work, but it would slow things down. And the whole promise of agents is speed, velocity, 1,000 commits a day.
Speed without stability is just a fast way to go off a cliff. Corn. I'd rather have 5 agents working at 80% speed with 0 conflicts than 10 agents working at 100% speed, but spending half their time fixing each other's mistakes.
Fair point. I'm a sloth. I'm all about that 80% speed, or even 20% if the coffee is good. But let's look at the practical side for a listener who is dealing with this right now. They've got a team. They're starting to use Claude Code or SWE agent. What is the first thing they should do to stop the bleeding?
First step, limit concurrency. It sounds counterintuitive, but don't run more than 3 or 4 agents on the same repo at once unless you have a very clear separation of concerns, like they are working on completely different microservices.
So, zoning. Give them their own neighborhoods.
Yes. Second step, use the get word tree approach we talked about. Give each agent instance its own physical directory. It prevents them from clobbering each other's local state or build artifacts. Third, and this is the most important, implement a semantic diff tool in your CI. Don't just look at line changes. Use something like TreeSitter to analyze if the structure of the code has changed in a way that violates your core architectural rules.
TreeSitter is a great shout. For those who don't know, it's a parser-generated tool that builds a concrete syntax tree for a source file. It's what powers a lot of the high-end code navigation in editors. If your CI understands the tree of your code, it can catch things that a diff would miss.
It really can. For example, if agent A renames a variable that is used in a string template in a different file, a standard diff might miss it, but a syntax-aware tool will see that the reference is now broken.
What about the human in the loop as a coordinator? Is there a world where the human isn't the reviewer, but the dispatcher?
That is essentially what agentic repository engineering is becoming. The human sits at a dashboard. They see a list of available agents. They drag and drop tasks onto them. But the dashboard, the orchestration layer, is the one doing the heavy lifting of ensuring that task A and task B don't overlap. We're moving from writing code to systems administration for code.
It feels like we are reinventing project management, but for robots. We spent decades trying to get humans to use Jira correctly, and now we have to teach robots how to not step on each other's toes in the virtual hallway.
The irony is delicious, isn't it? We thought the AI would just solve coding, but it has just introduced a new type of meta-coding problem. We are now debugging the coordinations of the code writers rather than the code itself.
I wonder if we'll see a standard for agent coordination emerge, like a trobots.txt for repositories, a file that tells any visiting agent, here are the rules for this repo. Don't touch these files without a lock. Use this naming convention. Always check with the supervisor agent at this endpoint before merging.
That would be a game changer. An agentic manifest file, tagentconfig.json. It defines the laws of the repo. If you're an agent and you don't support the repo lock protocol, you're not allowed to push.
I can see the GitHub protected branches getting a lot more sophisticated. Only allow merge if the agent coordinator is signed off on the semantic integrity.
We are already seeing the beginnings of that with things like required status checks that run complex AI-driven evaluations. But the real aha moment for me was source 3 in Daniel's notes, the idea that agents are currently work blind. They are great at the now, but they have no memory of what the other agent did 5 minutes ago in a parallel thread. Solving that shared memory problem is the key to everything.
Shared memory. Like a Redis for agents. A global state that everyone subscribes to. Agent B just changed the API endpoint for the user profile. Updating all context windows now.
That is exactly what is needed. If we could have live context streaming where an agent's context window is updated in real time as its peers make changes, the regression hell would vanish. But the token cost for that, oof. It would be like trying to run a video game where every pixel is $1.
Well, as models get cheaper and context windows get bigger and more efficient at handling needle in a haystack information, maybe that becomes feasible. But for today, we're stuck with more coarse-grained solutions.
Coarse-grained is better than chaos-grained. Even just having a daily coordinator agent that runs every hour, looks at all the open branches, and sends a conflict warning to the human lead would be a massive productivity boost.
So, to wrap this up, the chaos is real. The tools are currently immature, but the strategies are starting to crystallize. We need AST-based locking, we need intentional zoning of the codebase, and eventually, we need a shared memory layer so agents aren't working in silos.
And don't forget the staff engineer agent to prevent architectural drift. You can't just have 5 juniors running wild, even if they are really fast AI juniors. You need a voice of reason that keeps the vibe consistent across the entire repository.
A voice of reason. I like to think I'm the voice of reason here, but usually I'm just the voice of, let's take a nap and see if the agents fixed it themselves.
If only corn. If only. But the reality is that the more agents we add, the more human work we actually have to do in the short term to build the infrastructure that manages them. It's the automation paradox. To automate the work, you have to build a much more complex system to manage the automation.
Well, I think we have given people a lot to chew on. From intent-based commits to AST locking and supervisor agents, the path out of regression hell is starting to look a lot more like system design and a lot less like better prompts.
It's all about the architecture, man. It always has been.
Alright, I think that is a solid deep dive. Thanks as always to our producer Hilbert Flumingtop for keeping the gears turning behind the scenes. And a big thanks to Modal for providing the GPU credits that power this show. It is their infrastructure that makes all this agentic experimentation possible.
If you found this useful, or if you are currently battling a horde of uncoordinated coding agents, we would love to hear your horror stories. Search for My Weird Prompts on Telegram to join the conversation and get notified when new episodes drop.
This has been My Weird Prompts. Find us at myweirdprompts.com for the full archive and all the ways to subscribe. We will see you in the next one.
Goodbye, everyone.
Later. This episode was produced using Google Gemini 3 Flash. Text-to-speech by Chatterbox.
Thanks for listening to our show, My